Okay, so today we're going to be going over covalent bonding, and your objective for today is students will be able to draw Lewis-dot structures of covalent molecules that follow the octet rule. So we kind of already discussed this yesterday on how we go over drawing covalent bonds. So today we're just going to go ahead and continue and kind of like learn a little bit more or just solidify our learning from what we understood yesterday. There you go. Oops. So, drawing valence electrons on your Lewis dot structure. So, for instance, we're going to look at carbon. You notice right here in the center is carbon. Carbon has 4 valence electrons because carbon is run right here on the periodic table. Right, that's where carbon is located at. Well, if you notice, we're skipping the D block. So all the ones on the first column have 1. Second column will have 2. Skip this little part. All these will have 3. Look at where carbon's at. Carbon's on the 4th column. They'll have 4, 5, 6, 7. All the noble gases have 8 with the exception of helium. Helium is the only one that does not have 8. It has 2. Okay. So when we draw them, remember, we start, because carbon has 4 valence electrons, we can start at the top. We're going to draw 1 here, 2 here, 3 here, and then 4 here. Notice that I did not draw them 1, 2, 3, 4. No, we have to give them 1 to each side before we can double up. All right, so what is the difference between ionic and covalent bonds? Well, in covalent bonds, we're going to be using 2 nonmetals. So a nonmetal and a nonmetal. Notice that your nonmetals on the picture are on the right side, right? And they're all in yellow. I mean, obviously in your periodic table that you're going to get, they're not going to have, it's not going to be colored, but they're going to be with nonmetals. Nonmetal, that makes a covalent compound. With covalent compounds, their electrons are being shared. Think of the word covalent. Remember valence electrons? So valence electrons. Think of the word co-captain. When you have co-captains, they're sharing the power. Not one has more power than the other. So for instance, in covalent compounds, they're going to share the valence electrons. Know that they are weaker than the ionic bonds because of the fact that they're sharing, and they cannot conduct electricity. Where if you have ionic bonds, right, it's between a metal, which metals in the picture below are in the periodic table below, it's in blue, and it's between a metal and a non-metal. The electron transfers from metals to nonmetals. So like the metal will give its electrons to the nonmetals, or the nonmetal will steal it from the metal. And they're strong due to the difference in electronegativity. Remember, fluorine, which is F, if you look over here, fluorine is the most electronegative element on the periodic table. Put electronegative. So basically, because of the fact that your metals are far away from your nonmetals, they have a big difference in electronegativity. And because they have a big difference, remember when they share or give up their electrons, they're going to get charges. And then opposite charges attract. So that's how they are attracting each other, through the electrostatic attraction. And then also they conduct electricity. I do want you to know that just because you have a metal and a nonmetal, you can have 2 nonmetals and 1 metal. Just as long as there's a metal in there, it's going to be ionic. The octet rule, think of the word octo. It comes from the Greek prefix octo for 8. Like think of the word octagon, octopus. Octagons have 8 sides, octopuses have 8 tentacles. Well, the octet rule in chemistry means that every atom wants to have 8 valence electrons in their outermost energy level, like right on the outside. So all atoms in the periodic table want to have 8, except with the exception of 2 of them. There's 2 that do not want 8. The exception is hydrogen and helium. If you look at the periodic table, hydrogen and helium are on the first energy level. So they only fill up the first ring. And on the first ring of an atom can only hold 2 electrons. That's why they only want 2. All right, so now this is your problem. You guys should be doing this on Pear Deck. So practice problem number 1. First, I want you guys to go ahead and draw the Lewis structure for CH4. Well, just for the C, for CH4. Start with step number 1. Draw the Lewis structure of the central atom. So just only do number 1. We're going to go ahead and fill in the C. Right? We're going to pick our central atom. Our central atom is C, carbon. Right? Because it can never be hydrogen. Remember, that's one thing that you need to remember. that it's the least electronegative element that's going to be in your central atom. Remember, fluorine is your most electronegative. So anything far away from fluorine will be it. But remember, it can never be hydrogen because hydrogen can only bond to one other thing. So we're going to put carbon in the center and draw the valence electrons. Carbon has 4, right? 1, 2, we skip the middle part, 3, 4. So we draw the 4 valence electrons around the carbon. All right, now on step number 2, I want you guys to go ahead and draw the Lewis structure of the surrounding atoms. So now add in the H's. Go ahead and pause. Mind you, I'm going to be checking your Paradex. Now that I put you on student paste, I'm going to be checking on them. Make sure, I'm going to check that you're doing it. So go ahead and pause, that way you have time to draw. Okay, so hopefully you guys already drew it. Put play or something, I don't know. So now put play. You're going to have to be pausing and playing a lot. So you have to draw 4 H's around. Because hydrogen is on the first column of the periodic table, it has 1 valence electron. So it should look something like that. Now, go ahead and in a bit, you're going to pause. I want you guys to go ahead and connect around step number 3. Connect the single electrons with the lines. So notice that carbon has 4 single ones and each hydrogen has 1 single one. You're going to go ahead and bond them. Make a line. Go ahead and pause now. You guys paused. I don't know, it's weird. Alright, so what you guys should have done. Should have looked something like that, where you bonded all of the single ones. Now, go ahead and redraw it, make it nice. You want to make sure that all your lines are straight and perpendicular, you know, they're symmetrical. Not one line is bigger than the other, like here, it's like all slanted. No, you want to draw them nice. Yeah. Okay, go ahead and pause now. Draw it, please. Okay. It's I don't want to wait for you guys to draw. So go ahead and hopefully you press play already. So this is what it should look like. Voila. It looks pretty. So notice that on carbon, each carbon has 4 lines. Well, there's one carbon, has 4 lines. They all connect to the hydrogens. That's what it looks like. Notice that the lines are very straight, they're symmetrical, they're perpendicular, and all of them match. Alright, now my next question to you. Does CH4 follow the octet rule? Note that carbon wants 8 electrons. Hydrogen only wants 2, right? Because it's on the first energy level. Go ahead and pause and answer the question. Pause now. Okay, hopefully you already clicked play. We're gonna continue. So, does carbon follow the octet rule, and does hydrogen follow it? So first, let's look at the hydrogens. Yes, hydrogen does follow the octet rule. Well, even though it is the exception, each hydrogen wants to have 2 electrons, right? That's what it says on top. It wants to have 2. Well, here, each line represents 2 electrons. So out of hydrogen, there's no leftover electrons, right? There's no more floating dots. But I do see that one line coming out of the hydrogen. Each line represents 2 electrons. So yeah, it has 2 electrons, and that's exactly what it wants. Now let's look at the carbon. I don't see any electrons over carbon, right? But I do see 4 lines coming out of carbon. Each line represents 2 electrons. So 4 times 2 is 8. So yes, it does follow the octet rule. All right, practice problem number 2. Now I want you to draw the Lewis dot structure for NH3. For step number 1, go ahead and fill it in. I want you to draw the Lewis structure of the central atom. So pick between N and F. Which one goes in the middle? Is it N or is it F? Go ahead and pause and answer the question. I accidentally paused it myself. Well, you should have chosen nitrogen to be the central atom. And then how many valence electrons does nitrogen get? 1, 2, 3, 4, 5. It would get 5 because it's in the 5th column. So 5 dots around the element symbol. And then note that when you draw them, you should put 1 on top, then 2, 3, 4, and then 5. All right, you do give 1 to each side before you double up. All right, now go ahead and draw on number 2 the surrounding atoms. So now add the fluorines. Go ahead and pause, work on that now. I'm going to be checking your work. Okay, hopefully you already played it now. Now we're going to put the fluorines around the nitrogen. How many fluorines do we draw? Well, if you see it's NF3, that 3 represents how many fluorines we should draw. So we're going to draw 3. Boom, right here. Remember, we draw it on the sides first, then we draw it on the bottom. So here I drew 3 fluorines. Now, on number 2, or number 3, next thing to do is connect the single electrons with the line. Go ahead and pause so you can connect them. All right, now we're going to connect the lines. So if you notice that there's a single one on the bottom of each fluorine, right? The bottom, they have single ones there. And then on nitrogen, they have the 3 single ones. So each one bonds, because the singles, they like to mingle. Like that, just like that. Amazing. Okay. Now the singles, they like to mingle. And next thing we do on number 4 is we're going to go ahead and redraw it. Notice that the lines are in a slant. They're not straight. Look at this one at the bottom. It's going straight through the F. Some of you guys may have drawn it like around the F. But that's not a line. So we're going to draw it and make it nice. What I definitely want you guys to do is draw the dots, the single ones, facing the F. Or you can transfer these lone pairs to the bottom part or to the side. So are you guys ready? Pause your video. All right, now it's time to reveal the answer. Boom, there it is. So here you have nitrogen in the center, and then you have the lone pair on top, and then you have 3 fluorines on the side. Note that we just moved around the lone electron pairs. So the electron pairs are whenever you have 2 electrons together. So this is a pair, this is a pair, and this is a pair. With this nitrogen, we have a pair right there on top. So those are electron pairs, or lone pairs you call them as well. So we just move them around. That way, the single ones that were initially there are facing the nitrogen, and then they can create 3 bonds that there's the same size, they're perpendicular, and they're symmetrical. All right, now can you guys tell me, does this NF3 follow the octet rule? Know that nitrogen wants 8 valence electrons, and fluorine also wants 8 valence electrons. Go ahead and pause and answer the question. Okay, now we're going to go ahead and see if fluorine follows the octet rule. First thing we need to do is count how many electrons it has. So I'm seeing 1, 2, 3, 4, 5, 6 electrons, and it has 1 line. Remember, each line represents 2 electrons. So 6 plus 2, that is 8. So yeah, fluorine does follow the octet rule. Because remember, each bond represents a electron, or 2 electrons, sorry. Now let's look at nitrogen. Nitrogen, I see, has 1 lone pair, but it also has 3 bonds. So if we were to count each one, so it's 1, 2, so 1, 2, each one represents 2, so here we have 3, 4, 5, 6, 7, 8. So yeah, it would have 8. Or you can count the lines first. So since there's 3 lines, each bond, right, look here, 1 bond equals to 2 electrons. So, oh, my tablet's running low. 1 bond is equal to 2 electrons, so 3 times 2, that gives me 6, plus the 2 on the top, that gives me 8. So yes, it does have 8. So 2, 4, 6, 7, 8. Yeah, it does. It follows the octet rule. So this molecule does follow. All right, practice problem number 3. Go ahead and draw the Lewis dot structure for CF3Cl. Start with number 1. Go ahead and draw the Lewis structure of the central atom. So you pick the one that goes in the middle. Which one would go there? Between C, F, and Cl. Go ahead and pause the video and choose your answer. If you guys chose the one that goes in the center is your least electronegative element on the periodic table. Remember, it can never be hydrogen. And we're choosing the least electronegative element. The most electronegative element is fluorine. Right? Does everyone see where my fingers are? Fluorine is the most electronegative element. Now let's look for, it's the most. We want to pick the least. So chlorine is right below, which is very close, so it's also highly electronegative. And then you see carbon over here, which is a little bit further away. So which one's the least? Is it chlorine or carbon or fluorine? Well, we said fluorine was the most. So anything farther away from carbon, from fluorine, will be the least. So carbon is less electronegative. So that's the one that goes in the center. Don't forget to draw the valence electrons around it. Remember, it's on the 4th column, so it gets 4 dots around the nucleus. Next, now we're on step number 2. Go ahead and switch the slide. We are on CF3Cl. Go ahead and draw the surrounding atoms on there. So, you need to draw, go ahead and pause the video. So you should have drawn 3 fluorines and 1 chlorine, right? Each fluorine, if you look at your periodic table, I keep bringing mine up, has 7 valence electrons, and I'm sorry you can't see my numbers on there. Each chlorine also has 7. So all the fluorines and chlorines should have 7 valence electrons. Let's move on to the next slide. Here we have the fluorines and the chlorines. All we're going to do is connect the single dots, right? So that means I'm going to connect this one to this one, this one to this one over here, and this one over here. Look how I did my lines. They're not symmetrical at all. Go ahead. Oh, I forgot to tell you guys to pause. So you should look something like that. Now, go ahead and pause and redraw it and make it look nice. Go ahead and pause. Hopefully you guys are back. And please pause the video. When I say pause, pause it. You're going to redraw it. Make it look nice. I'm going to see how you guys drew it. It should look something like this. Notice that I drew all my lines even. My bonds are even. They're all the same size. Not one is longer than the other. And then I drew all the elements outside as far apart as possible. So if I drew one going to the side, up, down, they're all the same. And each one has the remaining lone pairs. Alright, can you guys tell me, does CF3Cl follow the octet rule? So carbon, fluorine, and chlorine all want 8 valence electrons. So look at the one there. Does it follow the octet rule? Go ahead and pause and answer the question. So pause. So let's look at our chlorine. Does chlorine follow the octet rule? So how many electrons does it have? It has 6. Oh, we're doing fluorine first. Well, anyways, it's the same thing. Fluorine has 7 valence electrons, but right now the remaining ones on here, there's 6 of them. And there's 1 bond coming out of it. So each bond represents 2. So the 6 electrons plus the 2 from the bond, 6 plus 2, it gives me 8. Same thing with chlorine. Let's check it. Chlorine does follow the octet rule. Same thing, it has 1 bond, which means there's 2 electrons on there, plus the 6 electrons that are left over, that gives me 8 as well. Now let's check carbon. Carbon is the one on the central atom. Carbon has 4 valence electrons. 4 valence electrons, and it created 4 bonds. Each bond represents 2 electrons. 4 times 2, that gives me 8. So yes, this molecule does follow the octet rule. Alright, now this one you don't have to draw on. but it's how to draw a double bond. We did go over this yesterday, except we used the example of oxygen. If you look for sulfur on your periodic table, sulfur also has 6 valence electrons. So that's why it has 6. Notice that 2 of them on each sulfur are single. Next thing you would do is bond or like connect the single ones. So because there was 2 single ones on each one, we're going to connect them. Note that I didn't put the single ones together because they're not going to be able to connect to anything else. So those single ones connect, and then it creates a double bond. But you need to draw it nicer, right? Because this doesn't look pretty at all. So you notice that like one line is bigger than the other. They're kind of curved, not straight at all. You're going to go ahead and draw them where they're straight, just like that. And that is it. You can also check to see if it follows the octet rule. If you count, it has 4 single electrons and then 2 bonds coming out of the sulfur. And we know that since there's 2 bonds, each is 2 electrons each. So 2 times 2 is 4, plus the 4 electrons that were there. 4 and 4, that's 8. So yes, it does follow the octet rule. Alright, now this is where you can draw. I want you guys to go ahead and draw the Lewis structure for the central atom. So go ahead and draw the remaining valence electrons on carbon. Go ahead and pause. You should have drawn how many? 4 dots. And you give 1 to each side. Now, can you guys go ahead and draw the oxygen? Oh, I already drew the oxygens for you guys. Can you guys draw how many valence electrons each oxygen gets? Y'all should have chosen that each oxygen gets 6 valence electrons. Oh, I forgot to tell you pause. Pause. 6 valence electrons. So now each oxygen has 6 valence electrons. Now we can bond the single ones. Go ahead and pause and bond the single ones. Pause. Bond them. All right. You guys did a great job. Hopefully you all did it. I don't know. Well, actually, I do know. I'm going to be checking your work. So if you bond the single ones, notice that there's 2 single ones on each oxygen. So it should look something like this, where you draw them a lot nice and neatly. Next step is to draw them a lot nice and neater. Notice that these are all curved. They're not even like that straight. Yeah, we gotta draw them where they're straight. Beautiful. This is how they look when you redraw carbon dioxide. Notice that the lines are symmetrical, they're even, they're in a straight line. And then we draw our lone pairs on the sides. Notice that I did not draw all the 4 together because they're also repelling each other, because electrons and electrons are repel. There's electron-electron repulsion. All right, let's go ahead and continue. Now, I want you guys to draw CCl4, carbon tetrachloride. That's what it's called. Pick your central atom. You should have chose carbon as your central atom. Drawn the 4 chlorines on the outside. Oh, go ahead and pause. Sorry. Drawn the 4 chlorines on the outside. And then you put how many valence electrons they have. Carbon has 4, chlorine has 7. And then you connect all the single ones. Should look something like this. This is carbon tetrachloride. Note that the lines are all symmetrical. They look nice and pretty. Alright, this is your exit ticket. When you are done with the video, do not log off. Your exit ticket needs to be drawn through Periodic. If you did not draw it on Periodic, so I'm going to be checking this, especially since you guys are watching non-live. I need to know if you guys are doing it correctly or not. This is the last slide. But yeah, well, I mean, you guys are live with me. I'm sorry, I'm getting distracted. Anyways, draw the complete Lewis structure for pH3 and N2. When you get here and you finish drawing, give me a thumbs up in the chat. This will let me know that you are done. You're not allowed to log off the call yet. We're going to wait for more people to join, and then we will go ahead and see the answers and explain. But I do want you guys to come back together during this part. Alright guys, so don't forget, give me a thumbs up in the chat. That way I can review this. I'm gonna go ahead and pause.